Physiology. For this chapter, I'm going to talk about aerobic and anaerobic energy production. We'll talk a little bit about skeletal muscle, how we fuel exercise. I'll introduce and discuss VO2 max, ventilatory and lactate thresholds. Talk about creative exercise testing and those responses. We'll cover endurance training and detraining, look at differences based on sex and cardiovascular responses, and a little bit about heat loss during exercise. So whenever we're moving, the currency of movement in the body is ATP, or adenosine triphosphate. If you think about how the body is designed, it's really kind of incredible. We have the ability to have short outbursts of energy, and then we have the ability to create movement throughout the day. For example, walking from point A to point B, no big deal. If somebody jumps out from a building and scares us and we have to jump away quickly, we have the ability to do that. So we can feel short, explosive movements. An example from the athletics or performance world would be the shot put. And then we have things that we can utilize, produce ATP for longer things like, say, a 5K or a 10K or a half marathon, or even a full marathon, even an ultra marathon. So for short-term bursts, we use anaerobic resources, and that means without oxygen. So basically, we're using creatine phosphate or phosphocreatine that exists in the muscle, so that it's there, nothing has to happen, nothing has to be transported. It's there, and it's very explosive. So we're usually breaking down creatine phosphate, phosphocreatine, or carbohydrates through glycolysis, and that provides rapid sources of ATP, this adenosine triphosphate, which we need to contract and relax muscles. And then we have aerobic sources. We can still burn carbohydrates, but we can also break down fats and use those. That's for prolonged exercise lasting 2 minutes or longer. ATP is supplied by aerobic metabolism. Okay, and that takes place in the mitochondria of the muscle. So here's a sort of a summary table. Immediate source energy sources. We have anaerobic, short-term energy sources for anaerobic, and then long-term energy sources or aerobic. So let's look at immediate energy sources. So if you have to sprint to get away from something, if you have to jump, if you're doing a 50-meter or 100-meter dash, you're using adenosine triphosphate and phosphocreatine system. Maximal work, 1 to 5 seconds. So if you give all out max effort, you're typically 1 to 5 seconds. If you're trained, it can be a little bit more, but not much. Examples from the performance world: shot put, vertical jump, 50-meter dash. So you can also have short-term energy sources that are not immediate, but a little bit longer. Those are anaerobic. We're going to break down carbohydrates, which is glycolysis. So breaking down carbohydrates, it's called glycolysis. And then we're looking at anything max effort for less than 2 minutes. Example, 200 to 400 meter race. If you're in a 100-meter swim, if you're sprinting, say you're playing a soccer match or an ultimate disc, and you sprint to receive the frisbee or the disc or the soccer ball, you can't sprint forever, but you can sprint for 100 meters or so. And then long term, we use aerobic, occurs in the mitochondria. We can break down stored carbohydrates. Carbohydrates stored can be stored as glycogen. We're breaking down glucose and then plasma fatty free acids. So that's what FFA is, fatty free acids. This is maximal work, 2 minutes or longer, and then all sub-maximal work. An example would be a 1,500 meter race, marathon, 5K, 10K. Let me show you a graph that might help explain this. So initially, if you're going to do any activity, to take that first step, you have to have some ATP present. So we have ATP present in very small amounts, and we also have creatine phosphate in small amounts, and we can produce ATP through this creatine phosphate. So it's great because it's immediate and it's very intense, but we're limited. And so as soon as I start utilizing that ATP, I'll replenish my creatine phosphate stores. So I can't use the anaerobic forever. The cool thing is the aerobic means they start to kick in immediately. They just don't contribute much. So here the anaerobic is contributing immediately, but then the ability to sustain that diminishes rapidly. Fortunately, we have such a coolly designed physiology in our bodies that this aerobic portion is starting to contribute, and then as we lengthen in minutes, then the aerobic is contributing the majority of ATP. Well, we also have muscle fibers that are better at being aerobic, and we have muscle fibers that are better at being anaerobic. If you think about chicken, I don't know if you like chicken, but if you think about a chicken, the thigh, and how it's dark meat and how it's nice and juicy, think about a chicken. The chicken walks around all day pecking for bugs. So their thighs are aerobic in nature. They utilize oxygen to produce ATP, and they can do that all day long. Well, since they're breaking down fats, you have intramuscular stores of fat, and that's why dark meat is so juicy. Now think about their breast meat. It's white, it's glycolytic. You don't see chickens fly. When they do fly, they're getting away from danger. So they'll flap, 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 get away from danger, and then they'll start walking fast using their legs. So next time you're at dinner, ask for some type 2 fast glycolytic muscle fibers, see what they do. So the most anaerobic is the type 2X, or fast glycolytic. It has a fast rate of contraction. It can produce a high amount of force, but it fatigues easily. On the other extreme, we have type 1, which is slow oxidative. The contraction is slow, however, it really resists fatigue. So low force, but fatigue resistance, and that's aerobic. You have an intermediate fiber, which is type 2A. It's fast oxidative glycolytic. It has fast contraction, high force, it resists fatigue, and the ATP is produced both anaerobically and aerobically. So training affects these type 2A muscle fibers. When you train, you don't convert type 1 to type 2X or type 2X to type 1, but these type 2A intermediate muscle fibers can assume characteristics based on habitual behavior. Here's a stain showing those in a typical muscle. You have type 1 darker, type 2A fast oxidative, and type 2X or type 2B fast glycolytic. Our muscles are composed of all three types of muscle fibers. This is determined genetically, which is why you have some people that are prone to be very fast or prone to be very aerobic. Most of us are somewhere in the middle. So if you look at type 1, type 2X by gender, we have type 1, so muscle fiber type distribution, average male and female. So type 1, which is 52%, and then type 2X, 13%, and the balance is 33%, which is type 2A. So distribution is highly variable, and it's influenced by genetics. And training does not convert fast-twitch fibers to slow-twitch and vice versa. Training does increase mitochondrial number and capillary density, which can make us more oxidative and utilize type 1 more effectively. So if you look at fiber types, If you look at exercise intensity, light to moderate, we have type 1. If you look at moderate to vigorous, you have type 1 and type 2A. And then vigorous is type 1, type 2A, and 2X. So what this means is, if I'm doing something at a high intensity, I'm recruiting type 1 muscle fibers first, then 2A, and then 2X. That's why we like to do HIIT training or higher intensity training instead of just having people go slow all day long. I can't recruit 100% of my muscle fibers unless I increase that intensity. Now, for some people, you can do that through intervals, and what is intense or vigorous for me might be not very intense for you. So even with rehabilitating seniors, we can utilize some intervals to engage all muscle fibers. Because to get all muscle fibers, we have to have higher intensity. But there is a pattern of recruitment. And that pattern of recruitment going from light to vigorous intensity starts with type 1 and then goes to type 2A and finally 2X. If I'm going at 70% of my VO2 max, my VO2 max is that intensity where I'm utilizing oxygen to produce ATP and I can't go any harder. That's my VO2 max. 70% of my VO2 max, I'm using all muscle fiber types to contribute to movement. Here's another way to show that. So the percentage of active muscle fibers, as I increase intensity, I go from type 1 to type 2A. Look at the significant contributions of type 2A. So even though type 1 muscles are being recruited, has less of a contribution at higher intensities. And then when I'm at 100%, I'm utilizing type 1, type 2A, and type 2X. This is a great schematic to explain muscle fiber recruitment. And the muscle fiber recruitment is based on size. So we have type 1 is smaller, and then the intermediates are a little bit bigger, and then type 2 are the larger motor units. And so the recruitment threshold is easier for type 1, which is why they're recruited initially. And then as the signaling increases, and as I need higher force production, there's an increase in the electrical current. So that allows my body to recruit type 2 muscle fibers to produce this higher force. Up into multiple parts. So stay tuned for part 2 and part 3.